Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. So I think JD is correct that this is a tough question to comprehend. It's a yes-no question asking, can something be the case? And you might think, well, anything can be the case. It's like if they ask, can X be 7? Well, any statement about X would answer that. Even if they say X is positive, can it be 7? Yeah. What if they said X is negative? Can it be 7? No. Either way, it would be sufficient. I can't think of any statement about X that would be insufficient for a question asking, can X be 7? Think about that. Can you come up with a sentence, with a statement that would be insufficient? A statement about X that would be insufficient to answer the question, can X be 7?
But what if it's saying X is odd?
Yeah. Can it be 7 if it's odd? Yes. Sufficient. Do you see the difference there between asking, is X 7 versus can X be 7? If they're asking, is X equal to 7, I can think of many statements that would be not sufficient. X is odd, X is positive, X is more than 5. Each of those would be insufficient, right? Because X could be 7, but it might not be. I don't know if X is 7 or not. But if they're asking, can X be 7? I can't imagine any statement about X that would be insufficient. And I think that's, JD, what's driving you absolutely crazy about this question. Like, how do you have a data sufficiency question that starts with the word can? I mean, in most cases, that would be nonsensical. If they were to ask, can X be 7, for example, that's a nonsensical data sufficiency question. Because any statement about X would automatically be sufficient. And that's why you're having such a hard time with this language. Starting a data sufficiency question with the word can is really weird. And it wouldn't make any sense for a simple question, like, can X be 7? That's a simple question, right? Can X be 7? That's a nonsensical question for data sufficiency. But what we have in front of us is a more complicated, a more nuanced question. And it reminds me of another data sufficiency question I've seen. What is this question really asking?
Is M a factor of N?
Exactly. So rephrase that is, or alternatively, if you prefer, is N. There are two more ways you could do this. Is N a multiple of M? And finally, does M divide N? That's a less common way to ask that, but it's also accurate. So I have 4 different rephrases of the original question, and what's interesting is that in all of them, what they all have in common is we've converted the word can into is or does, which is a much more sensible yes-no question for data sufficiency. And the reason we were able to convert the can into the word is because the question itself was a complex, nuanced question. It wasn't just asking, can the value of something be something? It's a much more complicated question. And that's what we have going on in this question. So to help us better understand this question, I think what we should do is start writing down some positive integers, because we know that n is a positive integer. And so literally start with 1, 2, 3, 4, 5, 6. Let's say the first 6 positive integers, write them down, and ask for each of them, Can this be written as the sum of two different positive prime numbers? Let's go one by one. Can the number 1 be written as the sum of two different positive prime numbers? So you've got a no and a no. What about 3? Can 3 be written as the sum of
No.
two different positive prime numbers? No. How about 4?
No.
Could be 2 and 2, but those are not different. Right? It has to be different. So this is also a no. What about 5?
Yes.
How about 6?
No.
Okay. So of the first 6 positive integers, only one, namely 5, only 5 can be written as the sum of two different positive prime numbers. All the other ones cannot. And the question is asking about n, right? Can n be written? So I can already tell you right now that if a statement were to tell me n is less than 6, would I say that that's sufficient or insufficient if a statement told us that n is less than 6?
It's insufficient.
Insufficient, that's right. Because if it's 5, we get a yes, but if it's any other number, we get a no. So this would be not sufficient. On the other hand, if a statement said n is less than 5, that would be sufficient. Because all of the positive integers under 5 lead to the same answer.
Just one follow-up on the 5. So I know that 5 is 3 plus 2, but when I was doing the problem, I thought, well, actually, you know what? 5 can be written as 4 plus 1.
Yeah.
And I thought, well, it can, so it's not sufficient because I can add 3 plus 2 or 4 plus 1.
I wonder what the language would have to be for what you said to make sense. Maybe if they had the word only in here, right? Can it only be written as the sum of two different positive prime numbers? And there's no other way to write them as a sum. Actually, I think the better place to put the only would be here. Yeah, I'm struggling a bit to come up with a specific language that would cause your concern to be a real concern. But if you think about it, JD, every number can be written as the sum of two different positive numbers, except for 1 and 2. But from 3 on, like 3, you could do 2 plus 1. 4, you could be 3 plus 1. 5 could be 4 plus 1, and so on. So every number from 3 on, you could write as a sum of two different positive non-prime numbers, because 1 is not a prime. So that's kind of not an interesting, like, yeah, any number could be written like that. But what they're interested in is, can the number be written as the sum of two positive different prime numbers? And 5 can be written that way. 1, 2, 3, 4, 6 cannot. Now, as I look at the statements, I'm thinking the cases that we have in front of us, we only wrote down these cases in order to help us comprehend what the question is asking. But since we already have these 6 cases in front of us, do you see how neither statement is sufficient on its own? Because statement 2 allows for these 2 cases, which lead to different answers. And statement 1 leads to these 2 cases, which lead to different answers. So we're down to C versus E. And I think this is where it gets a bit more interesting. If we combine them, we know that n is 5, 7, 9, 11, 13, etc., all the way to infinity. We already know that 5 leads to a yes. Would all of those numbers lead to a yes? Right? Is there something special about the odd numbers from 5 onwards, such that every single one of them can be written as the sum of two different positive prime numbers? Now, here's what I'm thinking. Other than 2, all of the primes are odd. So if you were to add together two different prime numbers, again, other than 2, you'd get an even number. But we are here looking at only odd numbers. So the only way you're going to get an odd number by adding two different positive primes is if one of them is 2. And that can really help me go through this very quickly, because if I have to use 2, this would be 2 plus 5, this would be 2 plus 7, this would be 2 plus 9, this would be 2 plus 11, and so on. Now, the 2 and 5, that's good. The 2 and 7, that's good. They're prime. 2 and 11, that's good. They're prime. Those are all yes. But the 2 plus 9, 9 isn't prime. So can 11 be written as the sum of two different primes? No. How am I so confident that it cannot? Because the only way you're going to get 11 by adding two different primes is if one of them is 2. Because if neither of them is 2, then you'd get an even number, and 11 is odd. So one of them has to be 2, but if one of them is 2, what's the other? It has to be 9. And that's the only way you can get 11 by adding two different primes, but 9 isn't a prime, so no, you cannot write 11 as the sum of two different primes, and therefore the correct answer is E, because even when we combine the statements, we were still getting yeses and nos. Hey, I'm just going to interrupt my own video for a moment here. If you're finding value in this video, please let me know in the comments below, and give this video a thumbs up. It really motivates me to keep uploading a new video every day. Alright, back to the video. And I can very quickly come up with more cases that would lead to a no. Because any odd number that is the sum of 2 and a non-prime odd number would lead to a no. So 2 plus 9, 2 plus 15, 2 plus 21, 2 plus, what's the next odd non-prime after 21? 27. Next would be 33, and so on. So I can tell you now that 11, 17, 23, 29, 35, all of those would lead to a no as an answer to this question, right? None of these odd numbers can be written as the sum of two different positive prime numbers, because 2 below each of them, you get a non-prime. And the reason I'm looking at 2 below is because 2 is the only even prime, and that's really the thing that this question hinges on. It hinges on our understanding that 2 is the only even prime number. And why is that significant? Because of the word odd in statement 2. That's the reason that the fact that 2 is the only even prime is relevant. I mean, I often tell people, don't obsess over the fact that 2 is the only even prime, because it's also true that 3 is the only prime that's a multiple of 3. And 5 is the only prime that's a multiple of 5. And 31 is the only prime that's a multiple of 31. Like, that's true for every prime. But I feel like people obsess over, oh, 2 is the only even prime. Yeah, of course it's the only even prime. It's the only prime that's a multiple of 2. Just like 7 is the only prime that's a multiple of 7. Like, there's nothing that special about 2. But in this question, there is, because they told us in statement 2 that n is odd. So they're giving us a piece of information about n in the world of divisibility by 2. Right? They're telling us the remainder when dividing n by 2. So the minute they bring that in as a statement, then it makes sense to quote-unquote obsess over the fact that 2 is the only even prime. Statement 2 forces one of the building blocks, right? We're talking about adding together two different primes. Statement 2 forces one of them to be 2. So if you know that one of them is 2, then that means that whatever number you're thinking of, take 2 away from that, and that will give you the other prime, the other number that's supposed to be prime. So that should lead you to think about odd numbers that are 2 above a prime versus odd numbers that are 2 above a non-prime. So that's where that 2 is so important. That again comes from statement 2. So statement 2 again forces one of the building blocks to be 2. which then means that if I'm trying to get a yes and a no, I want to think about different odd numbers where when I take 2 away from them, I hit a prime or a non-prime, and then that would lead me to different answers. And if you're thinking all of that, then you don't actually have to do anything, right? Because you just say, well, some odd numbers are 2 above a prime number, and some odd numbers are not 2 above a prime number, so I don't actually need pen and paper. Right? If I understand all of that, then I can just say, yeah, some odd numbers are 2 above a prime and some odd numbers are not 2 above a prime, and therefore the correct answer is E, and you're done. I think that insight from statement 2, that it forces one of the numbers to be 2, and then taking that to the next step, again, which is to say that therefore the other number is 2 below whichever number we're looking at. And can we tell whether a number that's 2 below some random odd number, I mean, all we know when we combine the statements, all we know is that it's some odd number from 5 and up. That's all we know. So when you look at, there's an infinite number of odd numbers from 5 and up, and you look at 2 below those numbers, well, that's still an infinite number of odd numbers. Are all of them prime? Are none of them prime? No, some are, some aren't. Therefore, it's E. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.